One of the most influential and progressive voices in modern physics, Dr. Michio Kaku, has recently spoken out about a discovery that could fundamentally alter our understanding of the universe. Kaku, celebrated globally for his contributions to both classical physics and quantum mechanics, has weighed in on the groundbreaking findings from the James Webb Space Telescope, JWST, a mission that has already begun rewriting the script of cosmic history. These observations, he believes, may not only challenge long-standing cosmological models, but also open the door to a new era in astrophysics. The discovery in question involves the detection of 6 massive galaxies, each formed during a period astronomers call the cosmic dawn, just 200 to 700 million years after the Big Bang. What makes these galaxies so perplexing is not just their early formation, but their sheer size and luminosity. Each one appears to contain more stars than our Milky Way, and some are forming stars at an astonishingly rapid pace, hundreds of times faster than our galaxy. According to existing cosmological theories, such galaxies should not have had enough time to form so soon after the Big Bang. And yet, there they are. These galaxies have been dubbed universe breakers by the Discovery team, a name that reflects the potential magnitude of their implications. If confirmed, their existence will demand a complete rethinking of how galaxies, stars, and possibly even the fabric of the cosmos evolved over time. This is not just a revision to a chapter in the cosmic story. It could mean rewriting the entire narrative. Dr. Kaku, a theoretical physicist known for his work in string theory and his accessible science communication, is not one to shy away from revolutionary ideas. Unlike many in the scientific community who prefer to cautiously defend existing theories, Kaku embraces new data with curiosity and openness. His reaction to the JWST findings is one of excitement, not skepticism. He describes these galaxies as among the most fascinating astronomical discoveries of our time and stresses the importance of thoroughly investigating what this could mean for our cosmic models. Throughout his career, Kaku has emphasized that while the laws of Newton and the equations of Einstein have laid a strong foundation for modern physics, they are still incomplete. They fail to fully explain phenomena at the quantum level, the true nature of gravity or the origin of the universe itself. He has long argued that we are in need of a more comprehensive framework, one that unifies the known laws of physics and embraces the complex reality of the cosmos. The JWST's revelations could be a key step in building that new framework. Current scientific models suggest that after the Big Bang, the universe underwent a prolonged dark age, a time when matter was too hot and disorganized for stars or galaxies to form. Only after hundreds of millions of years did the first stars ignite and begin to cluster into galaxies. But the JWST's observations seem to contradict this timeline. These newly identified galaxies are not small or primitive. They are mature, massive and active in star formation, traits that shouldn't exist so early in cosmic history. This poses a profound problem for conventional cosmology. Either our understanding of time and the age of the universe is flawed, or galaxies formed much earlier and evolved far more rapidly than previously thought. Both possibilities require a major overhaul of our existing scientific frameworks. Understandably, many in the field are reluctant to accept such disruptive implications. Some skeptics argue that these findings may be due to errors in measurement, particularly in redshift calculations, which are used to determine the distance and age of far-off celestial objects. Redshift is a phenomenon where the light emitted from an object shifts toward the red end of the spectrum as it moves away from us, a key piece of evidence for the expanding universe. Scientists use this shift to estimate how far away and how old these galaxies are. However, even small inaccuracies in these measurements can dramatically affect our conclusions about cosmic timelines. Because of this, researchers are now revisiting the data with a more critical eye, reanalyzing the calculations to ensure that the findings reflect actual cosmic anomalies rather than observational mistakes. But Dr. Kaku cautions against allowing outdated models to overshadow new evidence. He points out that in the history of science, many incorrect theories persisted for centuries, not because they were right, but because they were defended by respected authorities. In science, he asserts, it is the role of experimentalists to keep theorists honest. Without solid empirical evidence, theoretical models are speculative. Experiments and observations must always take precedence. Kaku also places the current debate in historical context. He reminds us that the Big Bang theory, proposed in 1927, itself faced fierce resistance. At the time, most people believed the universe was eternal and unchanging. The idea that the cosmos had a beginning, a finite point in time when space and matter were created, was difficult to accept. However, discoveries like the expansion of the universe, as demonstrated by Edwin Hubble, and the cosmic microwave background radiation provided strong support for the theory. These breakthroughs forced the scientific community to change its understanding. Now, with the James Webb Space Telescope's incredible capabilities, we may be facing another such turning point. Initially, astronomers expected the JWST to confirm and refine the details of the Big Bang model. Instead, it has unveiled phenomena that appear to contradict it. This doesn't mean the theory is entirely wrong, but it does suggest that it may be incomplete. In earlier times, scientists believed the stars were fixed in the sky and that the Earth was the center of the universe. These beliefs were eventually discarded as new observations and tools revealed a more dynamic cosmos. Likewise, today's scientists must remain flexible. Theories are not dogma. They are working models that must evolve as our knowledge grows. Kaku's willingness to entertain revolutionary ideas is what sets him apart. He finds humor in the anxiety some scientists experience when their cherished models are challenged, but he also recognizes the seriousness of the moment. If the JWST's findings hold up, they may reveal not only that galaxy formation happened much earlier than expected, but also that our understanding of physics, time, and cosmic evolution needs radical revision. As we continue to analyze the data, the scientific method demands patience, rigor, and openness. The redshift measurements and other observational data must be independently verified and subjected to peer review. Only then can the scientific community reach consensus. But regardless of the outcome, one thing is clear. The JWST is not just a telescope. It is a time machine, a window into the ancient universe and a catalyst for one of the most exciting scientific debates of our generation. In conclusion, the cosmos has always held surprises for those bold enough to look. The discovery of these 6 massive galaxies is a reminder that science is not static. It thrives on revision and reinvention. As Dr. Kaku has shown, the path to truth lies in curiosity, not certainty. The universe may be far more complex and wondrous than we've ever imagined, and with tools like the James Webb Space Telescope, we're just beginning to scratch the surface.